So in this question, we are given the yield stress, right? That is equal to 50 KSI, right? Now note over here that it is given in KSI, not in pascals, right? Now what we are required to do is that we need to determine the factor of safety, and it has two parts, right? First, we will determine the factor of safety considering the maximum shear stress theory, right? Maximum shear stress theory. And part B, where we will again determine the factor of safety use considering the maximum distortion theory, distortion energy theory, right? So let's start with part A. First, the solution is very simple, it's very easy. It's similar to the question that we have done before. So let's start with it. Now, we are given by the figure of the problem that sigma sub x is equal to 12 ksi, right? Sigma sub y is equal to negative 8 ksi, and sigma, sorry, not sigma, sub xy is equal to 7 ksi, right? Now for part A of this problem, we have to use maximum shear stress theory. For that, we would be using the equation 10.27, right? Now, to determine the correct version of that equation for this case, however, first of all, we need to find out the principal stresses, right? So, to do so, we need to use the equation 9.5. So, that is, let me write it over here. We have sigma sub 1 that is equal to sigma sub x plus sigma sub y divided by 2 plus under root sigma sub x negative sigma sub y divided by 2 whole square plus xy square, right? So just plug in the values. You have all the values. Just plug them in over here, right? I'm not going to do that step. I'm going to just skip it because that is just simply it's mere just putting in the values, right? So I'm not going to do that. I'm just going to write the calculated value. So that is 14.2065. That is approximately equal to 14.21 KSI, right? So this is your first principal stress, right? Now we need to calculate sigma sub 2, right? So again, we would be using equation uh, it is similar to this one. It does have negative over here and over here, right? So sigma sub 2 is sigma sub x plus sigma sub y divided by 2. Sorry, it has positive sign over here. The only difference from this equation and this equation would be this positive sign in the middle, right? So negative under root sigma sub x negative sigma sub y whole square divided by 2 plus xy square, right? Again, just plug in the values and you will get that sigma sub 2 is equal to 10 point negative 10.2065, right? And that is approximately equal to negative 10.21 KSI. Right. So now that we have our principal stresses, right? And as you can see that both of them are opposite in signs, right? One is positive and the other is negative, right? So it means that we need to write the correct form of the equation 10.27, right? And that would be sigma sub y is equal to the absolute value of the difference of sigma sub 1 negative sigma sub 2, that is equal to 14.21 negative 10.21, right? And that is equal to 24.41 ksi, right? Sigma sub y. Now, as you can see that this new found or new calculated value 24.41 ksi is less than 50 ksi, right? So it means that the material does not fail according to the maximum distortion distortion energy theory, right? And so it means that we can find out our factor of safety. So in this case it would be k, right? And this k is the ratio of the maximum yield stress the material can endure to the one enduring it, right? So it is uh, sigma sub y sub material divided by sigma sub y, right? Just plug in the value. So k is equal to um, 50 divided by 24.41, and that is equal to 2.0483, and that is approximately equal to 2.05, right? So I can say that the factor of safety is 2.05, right? So this concludes our answer for this part B, and this is your whole solution.